Hello, so today we're going to continue into the bonding unit and we're going to start talking about nomenclature, which pretty much just means the art of naming. And today we're going to focus on what's called binary compounds. So the first type of binary compound that we want to address is what's called diatomic molecules. So di meaning two, atomic meaning atom. So these are two atomed molecules, okay? Which means if they're molecules, it's two atoms sharing or forming a covalent bond. So binary compounds just in general are compounds that consist of two elements bonded together. Now compounds can refer to ionic bonding too. So there's two types of binary compounds in itself. There's molecules and then ionic compounds, which are salts. Binary compounds, like I said, can be both ionically bonded and covalently bonded. Ionically bonded binary compounds are just called as such, or they're called salts. So you'll hear me say ionic binary compounds or salts. And then covalently bonded binary compounds are what's called diatomic molecules. So diatomic molecules, although there's many diatomic molecules that we can form, there are a few elements on the periodic table that will be found diatomically in nature, which means when we go to grab this stuff in nature, they're always in diatomic form, which is very important because when these diatomic molecules are produced, when it comes to calculations that we'll do in what's called stoichiometry in next unit, the fact that they are diatomic molecules becomes very important within those calculations. So the couple of diatomic molecules that are included are the following. So bromine, iodine, nitrogen, chlorine, hydrogen, oxygen, and fluorine. So as it says, when we're naming these molecules, it's just the name of the element plus molecule. So diatomic molecules are just called the name of the element plus molecule. So bromine molecule, iodine molecule, nitrogen molecule, chlorine molecule, hydrogen molecule, oxygen molecule, fluorine molecule. Now, also you may hear me say that these are gases because these found in their normal states are gases. So with that, when it comes to this, you may hear me say bromine molecule or bromine gas, or oxygen molecule or oxygen gas. They're the exact same thing. So just be aware that they can both be called that. The thing is, you need to memorize these. Okay, I typically remember just Brinkelhoff. So Brinchlhof. So if you remember Brinkelhoff and you sound it out phonetically, and you write it on a test, and you just say, okay, all these elements are diatomic in nature, this will help you out. Well, you need to memorize these ASAP because they will become very important, not only in this unit, but especially in next unit as well. So we're going to go into what's called the crisscross method. This is how we really start bonding ionic binary compounds together, especially. So for ionic binary compounds, one particular method is this to use to determine the formula of the combined ions. So suppose I want to combine a calcium ion and a fluoride ion. So I have Ca2+, and then I have, in addition, with fluorine negative. Well, for the compound to be stable, the charges have to balance out. So what I have to ask myself is that I have a 2+ over here, and then I have a -1 over here. So to make that charge 0, for it to be neutral, I'm going to need 2 fluorines for that. Because if I times my 2 of fluorine's -1, then I get 2 plus -2, which is going to equal 0. Okay, and so this is going to form calcium fluoride, which is CaF2. And this is the reason why, because I need 2 fluorines for every 1 calcium to equal out that charge. But another way you can actually infer this is just by crisscrossing the charges. So what you do is that you take if they don't equal out, if it's not 2 and 2 and it's 2 and 1 in this case, you can take the 2 and put it down next to fluorine, which becomes the subscript for 2 here. And then you can take the 1 for fluorine up here of its charge and crisscross it down as a subscript for calcium, which 1s don't have to actually be in the formula itself. So this 1 from up here becomes the 1 that's invisible here, and the 2 up here becomes the 2 that's here. If the charges are the same, if you have a 2+ and a 2-, you don't have to do the crisscross method. You can just put them together and it's 1 of each, because you only need 1 ion of each to cancel out the charge. It's when you need more than 1 ion that you have to use the crisscross method. So when it comes to creating the formula for binary compounds, the cation always goes first, and then the anion. And that follows the nomenclature of naming these compounds too. So naming binary compounds, for the naming of it, the cation name goes first minus the ion. So before, with calcium, we said just the calcium ion by itself is just calcium ion. But when you put calcium ion together with something else, the ion drops off. And then the anion's full name goes next. So the cation plus the anion is equivalent to the compound. Okay, so if I take an aluminum ion and then sulfide, and I make aluminum ion plus sulfide, I take ion off, so then the resulting compound becomes aluminum sulfide. And then if I take a strontium ion plus an oxide, I have strontium ion plus the oxide, but I drop the ion off, and then I make strontium oxide. That's the resulting compound. So that's how the nomenclature for ionic binary compounds work. We'll add more to this in the next couple of videos, but just for the basic stuff, it's the cation minus the ion part of its name plus the anion's name. That's all you need to do. Okay. All right. So again, kind of a shorter video, but kind of pretty basic. If you have any questions in regards to this, please come see me or talk to me. That way we can kind of break it down more one by one. But just be aware that you'll be required to not only form ionic compounds based off the ions that I give you, but if I give you a name, you're going to have to be able to make that formula too. So be aware that you need to kind of do one way or another. So again, if you have any questions, please come talk to me, email me. Otherwise, thanks for joining me in this video, and I'll see you in the next one and in class. Bye.